So let's move on to our next speaker. Her name is Dr. Deborah Stacey at the University of Guelph, and her presentation is going to be on Fair to FAIRS, Data Security by Design for Global Burden of Animal Diseases. And all right, you're ready to go. Fantastic. It'll be your 10-minute warning, or your 5-minute warning will be at 9:13.
Thank you. I'm going to be talking about a project that we have ongoing for data security by design for the global burden of animal diseases, or what I'll refer to as GBADs. This is work by, it's a collaboration with myself and Teresa Bernardo, who is an epidemiologist in the Department of Population Medicine in the Ontario Veterinary College. I'm a faculty member in computer science, and we're the GBADs Informatics theme leads, co-leads. And we also have two amazing master's students. They're Kenneth and Nidip, and they are doing the Masters of Cybersecurity program at the University of Guelph. The global burden of disease for humans provides a comprehensive picture of what diseases and what disabilities and what kills people over time. So data on death and disability is collected and analyzed by a consortium of more than 3,600 researchers in more than 145 countries. So by qualifying the losses, it supports strategic investments in health systems to improve outcomes and reduce disparities. Similarly, the global burden of animal diseases will improve decision-making for animal health by integrating data from a variety of sources and sharing tools for analysis. Thus, it'll contribute to the Sustainable Development Goals of zero hunger, health and well-being, gender equality, responsible production and consumption, and economic growth. It's a Gates Foundation funded project which is slated to start in full in January 2021. And our website is animalhealthmetrics.org, where you can hear more about all of the different activities. And I put this in because just to emphasize how important this project is going to be. Pandemics aren't just for humans. There's an incredibly dangerous outbreak of African swine fever that is just hit Nigeria, where millions of pigs have to be culled. This disease has no vaccine. It's 100% lethal. And disease epidemics such as African swine fever is devastating for the animals, for humans, and for economies. So what we want to do in our work here is to look at the problem of data sharing. And what we're doing is starting with the definition. So if you look in things like Wikipedia or the Open Data Institute, their definitions of data sharing involves open data almost exclusively. But the world contains more than open data. And so what we want to look at is how do we handle private closed data in our research systems. So we have also cutting edge resources such as public cloud computing platforms, such as AWS from Amazon, Azure from Microsoft, and Google Cloud Platform. But many private data holders are leery of using these tools as they perceive that their on-premise infrastructure is more secure. So like others have been talking about, we need to generate trust for both the data owners and the users. And so how do we generate this trust between academia and industry? And we're going to be looking at the technical infrastructure and aspects of this. So our research goes around these statements, these questions. How can we answer these? Is it possible to balance data security and privacy for data owners with ease of use and continuous availability for researchers? And are there technical mechanisms that can help to overcome the barriers to trust between the providers and users of data? So what we want to start with is to explore the reality of data security in modern computing infrastructure. And to do this, let's examine briefly a few recent data breaches. So Data Deposit Box is a Canadian company that exposed unsecured and unencrypted user backup data in their AWS data storage repository in S3. It was a result of misconfiguration by their staff. A more embarrassing one is that Microsoft actually exposed user analytics data also because of a misconfiguration by their own staff in their Azure cloud platform security policies. Both of these breaches happened in the December 2019 to January 2020 timeframe. But probably more disturbing was the worst data breach that ever happened in Canada, which was to Life Labs, where over 15 million health records were left unsecured and unencrypted. Subsequent investigations, partially because of lawsuits, found that Life Labs, their entire security environment was flawed and under-resourced. But to illustrate what we're trying to look at, this wasn't a cloud failure. This was actually on-premise infrastructure. And so there was no safety in doing it all yourself and keeping it within your own company. So the lessons learned from this is that data breaches do occur in the cloud, but they're not that common. And almost all of the breaches in modern usage are of misconfiguration and not an inherent flaw in the cloud platform itself. So most of the breaches are entering. They're not breaking and entering because people have left the door open. So there's no real hacking that's going on in these platforms. It's really just poor education, misconfiguration, poor staffing practices by organizations. So just to reinforce this, and also another recent article this June, is that it was revealed that cloud security is already making denial of service attacks less of a threat. And just recently, in the recent past, denial of service was a very hard thing for organizations to protect themselves against. This is when you get flooded with all sorts of bogus requests and it shuts down your operation. There was an attack, 2.3 terabits per second, on AWS, the Amazon cloud service, and this is 40% bigger than any previous attack ever, and AWS didn't go down. In fact, this happened in February, and nobody noticed except AWS. So obviously not every platform is this robust, but the Amazon and the Google ones are incredibly robust against this type of attack. So the perception versus reality is something that has to be always looked at with technology. The cloud platforms, the public ones that we have security at a scale that's attainable by very few organizations, businesses, or even governments. This security applies to hardware, network staffing, geolocation. It's superior to almost any public-facing infrastructure currently available. Like maybe the NSA has infrastructure as secure as this, but you can't buy time on their servers. So if we looked at the causes of security breaches, if we want to examine the shared responsibility model in the cloud, and this separates out the responsibility of the platform, the cloud platform, and what the user has to supply for security. In all the platforms, almost all the heavy lifting for security is done by the platform itself. And they offer many security tools and best practices for those tools that users can apply to these architectures, such as audits, logging, sophisticated access control. And there is the remaining problem of misconfiguration, but we have best practices and a lot of education from vendors and other sources. So how do we mitigate these issues so that we can develop trust and use, particularly in the private sector, for using cloud platforms that would join public and private data? Well, we can look at using the robust set of tools that are in the cloud. It's a lot easier to do this in the cloud than it is to do it in your own infrastructure. And you even have things like compliancy standards and help with meeting compliancy standards such as the EU's General Data Protection Regulations or the GDPR, which really helps in being able to allow people to set up these very secure infrastructures. So what I want to concentrate on is this notion of this dichotomy between open data and closed data or private data. And I want to attack this by first looking at this set of guidelines that is established actually at starting at a workshop in 2014 called the FAIR Guiding Principles for Scientific Data Management and Stewardship. And they established a set of guiding principles to allow for data sharing. And if we look at these principles, they say data should be findable, accessible, interoperable, and reusable. And they talk about all sorts of different standards that we should be using, practices we should be using, and these have had a lot of impact on particularly open data sharing in the life sciences. And there are some excellent papers that reflect on using the FAIR guiding principles, including looking at one called the FAIR Guiding Principles for Data Stewardship's Fair Enough. And there, but people have been looking at how do we start from here and add on to that. So what I want to look at is how do we use these principles when the data isn't open? So why do we want to move from FAIR to FAIRS, where S stands for secure? We need private data, has to have security, it has to have privacy, and it has to have, there has to be trust. But so it's more difficult to look at, but its value is worth it, because often we can get access to information with these private data sets that we couldn't get with public data sets, including the notion of time, that the latency is not as great with a lot of private data. In fact, it could be streaming. So what we've done is we've supplemented FAIR to go to FAIRS, and we have 6 sub-principles that I'll now go through in detail. The first one is that all data are secure by default. And in fact, this is actually one of the principles for all of the current cloud platforms. Security has to be the first consideration. So we want to design with security in mind and use it to bind all the other principles together, not just. So we can see with our current pandemic situation that cyber criminals and threats come out in force during an emergency, and security now is recognized as a primary driver of design. So what we have to do is take all those other principles like finding, accessing, reusability, interoperability, and we have to design with the security in mind, so that security is integrated into all of those principles. 2, all data must have appropriate access permissions. Obviously, this is what everybody wants to do, and there's many tools to apply the principle of least privilege and in the cloud environment, where what you are using is function, not just identity, to drive rights management. And with this, one of the tools you can use is basing privileges on groups, not users. And so groups are given roles and functions, and that gives them they are then given various privileges to accomplish this. And it's much safer to, particularly with the misconfiguration aspect, to have groups instead of individuals being considered, because this makes a far fewer set of privileges that have to be defined, and it's much easier to organize and either revoke or apply. And with 4, what we're looking at is access methods that manage views of data. So we don't want to actually look at data as data. Yep.
I rang the 5-minute warning bell. I don't know if you heard it, so I just wanted to make sure that you're aware you've gone past.
Yep, I've got that. So
okay.
With views, what we want to do is we want to bring back a database idea about views where you only see part of the data or part of the data set, or in fact, you don't even see the data set, you see a virtual one. And so these are curated and monitored and much more appropriate in this kind of situation, where you can limit the degree of exposure, you can hide complexity, and you can provide extra security, because you may not actually be showing the actual data. It might be aggregated, it might be de-identified. Encryption, I don't think I have to talk too much about that, except to say that there's 2 types, protecting data in transit and protecting data at rest. There's lots of tools for that. We just have to make sure they're applied. And like FAIR, we want this idea that we really want to look at machine-to-machine security, because that's where most of the data transfer is going. And that means we have to provide end-to-end source-to-destination security. So how can FAIRS be implemented? We can do it by secure by design, secure by training, and secure at scale. So here's one of the potential architectures that our group is looking at. This is only one of them. We're doing this with AWS, but it's not, it's just as an illustration. The goal for the project is to offer a collection of architectures that are secure, scalable, and cost efficient. So to conclude, where for too long the data sharing conversation in academia has centered on the sharing of open data and the promise of convincing industry to openly share their data in some form. well, that's a laudable goal. It's not always realistic for some types of data. So what we want to do is we want to provide an architecture for data sharing across the spectrum of data modalities. And so we're designing these systems, we're going to put them out there, we're going to use them for GBADs, but we don't see that GBADs is the only trusted data broker architecture that could be out there. This architecture and the set of architectures we're designing right now can be used by many research institutes to link up with industry for the benefit of both industry and academia. So thank you.
Thank you, Deborah. David, do we have any questions yet?
Yeah, we have a couple of questions. We'll start off with questions related to data storage. As more ag data are added to repositories, should we expect more insidious attempts to breach data security methods?
I think we have to, because usually what happens is that things aren't attacked until they're seen to have value and they're noticeable. And so the more data that you have out there, the more access that people are going to want to have to it, or the more value they see to it, there's going to be more attacks. So I don't think there's ever going to be less attacks. It's always going to be more. And that's why like we're looking at cloud, because there's so many people working on cloud platforms that you get this huge workforce looking at security that you don't have to, like that you can take advantage of. So I definitely think it's only going to get bigger, it's only going to get worse.
Okay, and do you have a sense of corporate concentration in data management and cloud storage? How much power does Amazon have in this sector, and are there other big players with respect to data management and cloud storage?
Right. Obviously, the biggest by far is Amazon with AWS. They're the ones that they've been in it the longest. It's almost going up to 20 years now that they've had some version of this. They're the engine behind almost all of the major streaming services like Netflix or Dropbox or any of those major ones. They obviously are the ones that are attracting more. They have the biggest set of tools, the biggest staff. So there is a concentration on that, and there is a problem, obviously, with that. The next two services, the Microsoft Azure and Google Cloud, are much smaller. They're growing, but they're still much smaller. So there's a problem in committing to one of these public platforms because of the concentration, but there's huge advantages because of they have infrastructure that you can't match. The dispersion all over the world, the geolocation for most of these platforms is impressive. They're everywhere. I think maybe Antarctica is the only place that Amazon doesn't have anything, and I wouldn't doubt that they're going there. You know, so there is a problem with that, but there's also, I think, ways you can mitigate that, but to provide this level of security, you need scale. And right now, the only players in town are really those three.
Okay. Do you think there's anything we can learn from existing practices in the health sector when it comes to data breaches and security for agriculture?
Oh, yes, that's an excellent question. Obviously, health has all of the issues that we have in ag multiplied. I think what you can see if you look at the health sector is one of the problems with fragmentation. All of the health systems, like health records, are all controlled by all sorts of different units all over the world. There's not very many standards to group them all together. A lot of it is run by private companies that have had spectacular failures, just like I mentioned in Canada with Life Labs. The sector is fragmented between government, private, academic, and I think it's good for ag to look at that and see that there might be a way for ag to lead, because I think health to a certain extent has dropped the ball because they haven't figured out a way to bring everybody together.
Okay, we have time for one more question.
All right, just a comment for all presenters. Would they be willing to share their slides? And here's the last question. Can you explain how the architectures are set up to be reusable on non-AWS platforms? Is it a set of rules or specifications for each security configuration, or are already implemented in major platforms?
Great question as well. All the different things that we use in that AWS architecture, all of them are available in some form in all of the public platforms. So we can do a fairly robust mapping between all of the different platforms as to what functionality there is. There's slight differences of how they're implemented, and so that would mean that there would have to be some sort of customization, but not as much as you might think. Almost all of the systems provide similar kinds of products. The real task is to map these out, and that's one of the things that we're going to do, is show how the mappings can occur. So for the most part, you can do mappings to any of between one to the others.
Thank you.
All right, thank you. Just a real quick comment on slides. We're going to work with the authors to see about the availability of their slides following the workshop. And then also a lot of the contact information and details will be in the special issue that gets released in the spring.